Despite many advances in neuroscience, scientists still don't quite know how thoughts are formed, or how those thoughts lead to behavior. To understand that, they need to be able to find and control the neurons that are turned on during specific actions. While researchers have succeeded in identifying these neurons, controlling them has proved much harder, until now. Scientists at the Max Planck Florida Institute for Neuroscience recently built a new tool that does both. The system, called Cal-Light, works by using flashes of blue light coupled with calcium influx to trigger the production of proteins inside active neurons. These proteins can be fluorescent markers to label neurons, proteins that regulate activity to hijack neurons, or both. The trick is to time the light flashes with an action of interest. That way, the proteins used as labels or control switches are manufactured in neurons that fired during the action, which are presumably the ones responsible for it. The scientists first used Cal-Light to identify motor cortex neurons responsible for lever-pressing behavior in mice. They added the Cal-Light proteins to the motor cortex of thirsty mice. Then they shined blue light as the mice pushed a lever to get a drink. This procedure labeled a small group of neurons as active during lever pressing. To confirm that the neurons they labeled did in fact cause the lever pressing, the researchers used Cal-Light to turn the neurons off. They did this by producing a control switch in the labeled neurons too. This protein, called halorhodopsin, is activated by yellow light and stops neurons from firing. When the scientists shined yellow light on mice that already knew how to quench their thirst, the mice no longer pressed the lever. This confirmed that the neurons marked with Cal-Light were responsible for lever pressing. By labeling neurons that control specific actions and providing a means of controlling them, Cal-Light provides an unprecedented opportunity. Researchers might now have a way of understanding how neurons team up to generate thoughts and behavior better than ever before.